Right. Hello, everyone. Welcome to this session about transport mechanisms in GWT. I'm Leif Ostrand, way too technical product manager at Vaadin, and I'm here to hopefully let you learn about how to get things moving back and forth between the server and the client in your GWT application. I think the reason you might want to know this is, one, so you can choose a solution that works good for your project, and the second thing, so that when you have chosen what to use, they can also use it efficiently, because there might be different gotchas that you might need to be aware of. These slides, they are actually already online from the US conference. I will tweet about them again after this session so that you surely find the link if you're interested. And the last thing before we actually get started is just want to let you know that first we will look at some quite basic concepts, like really the fundamentals of how things can be communicated between the two sides. Then after that we will go into some more interesting ideas, some crazy stuff that people have come up with that can be good in some cases. And then finally, of course, I will take whatever tricky questions you have for me, and I might even have an answer to some of them. But let's get started. Transport. So, as I said, between client and server, the assumption is kind of that you have some kind of database or something running on your server, maybe some business logic as well, and then you have the UI on the client, and then those two obviously need to talk with each other. This happens over network. Most common case is HTTP. There's basically one other option that makes sense today, and that's WebSockets. I won't go into WebSockets today. They are interesting can of worms, someone has said, but basically they work in the same ways. It's like you send strings back and forth, and that's about it, although there's some other things to keep care of as well. But yeah, HTTP requests. So this is sample code, what it would look like if you were to do low-level HTTP request sending in GWT. The first thing to observe is that we have define what kind of HTTP request type we are sending, like GET or POST or whatever. And then you also need to have the URL. You need to know where you should send that message. Then for the actual sending, you have a string containing whatever you want to send. And then when you send it, you give it a callback, because this goes asynchronously. So we don't actively wait until there's a response. When there is a response, the callback gets notified. There you can check the status of the response, get a string with the response back, and then you do whatever you want to do with it. The last thing here to observe is that there can be different kind of errors. Some of them happen immediately when you try to send something. That's catch block there. But then others, like server timeout, for instance, those are part of the callback system, because those can happen at any time. In summary, this way of sending or communicating, the good thing about it is that it really works. It's really obvious. But then the bad part is that this is kind of low level. There's lots of different things you need to take care of, like all the different kind of errors, finding the URL where you want to send data, what you actually send, and all those kinds of things. But despite being really low level, quite boilerplate to use, in the future of GWT survey that some of you might have responded to, 8% of you said that, hey, this is the thing we use in our software. So it's still okay. It's not the biggest player, but it's still quite good. But as I said, getting actual request sent and getting responses back, that's not really the hard thing. The hard thing is to not where do I get those strings that I want to send? What do I do with the string I get back from the server? Another kind of challenging thing is also like, where do I send the stuff? That's also, okay, it's kind of obvious, but still not. We'll come back to that later. So now let's have a look at like what to actually send. We'll be looking at lots of examples sending a like contact class for some kind of address book application or something like that. So here you have like string name, integer, which is the year of birth, list of email addresses, and then also like a street address, which is just for the sake of the example here embedded in a separate object. And then of course this class would have getters and setters and everything. So the first really basic way of doing this would be to just like put all those fields together into a string by yourself, put like commas in between and whatever, and then when you get the data back, you just like split on the commas, and don't do it, please. Because there's like lots of things that can and will go wrong. What happens if there's a comma in the name? What happens if there's some strange non-ASCII characters in the name? Just don't do it. Instead, what you probably want to do is to use some kind of existing format that defines how all these things works. Two most popular ones are XML and JSON. Out of those, we will be focusing on JSON because it's really like more practical from the browser's point of view, whereas XML, it's older, slightly like legacy baggage, and also more optimized, more convenient when servers talking to each other, or like when you store things in a file or something like that. But in browsers, really like JSON is much more smooth to use for many reasons. So if we would take like one example JSON message sending one of those contact objects, it could look like this. There's really like, you could define it in any way, but this is kind of like the obvious way. JSON is just a subset of JavaScript, so this should be quite familiar syntax to all of you. But then what do you do when you get this as a string? Once again, the most obvious basic way would be using JSONValue that is part of gwt. So here you have like lots of code, some really nasty, or not really nasty, but kind of challenging parts. One is that this is in no way type safe. You need to know that here this should be a string, this should be a number. So he will like check using the JSONValue API that, okay, is this a string? Good. Then get the string value out of it. And then correspondingly, and even more tricky actually with numbers, because JSON only supports standard like 64-bit floating point numbers, so you will get a double out of the API. So then if you know that, hey, I have an int, then you need to take care of that for yourself as well. Once again, evaluating. Good parts about this, it's really standard. Anyone knows how to deal with JSON. The format is human readable, like what's sent, which makes it much easier to debug if you have some problems. Although that, of course, means that you might be wasting some bytes. But still also, like for being a human-readable structured format, this is very compact. You don't have many extra characters besides from the actual data that you're sending. Bad parts, it's not completely type safe, so you need to know that, hey, this is a string, this is an integer. There was quite much code there compared to some other examples we'll be seeing, so there's some boilerplate here. And then also the example I showed you, that code only compiles on the client because it's part of the gwt SDK, and there's no like server-side implementation of that one. There are some like pure server-side only implementations. We'll look at those soon. But there are also some other options, kind of similar options for the like client-side space. One of them being elemental JSON. That's also part of the SDK. That one is really like optimized for high performance, really efficient. The code is kind of the same amount of boilerplate. The good part is that that one also has a GRA implementation, so that one you can run on the servers. You can have the same like parsing code implemented for both sides, so they stay in sync. Yet another gwt option is to use either JavaScript object, like overlay types, or then JS interop to like define a native representation of your objects and then just like ripping data out of that like native JavaScript. But those are like slightly less boilerplate, but then you're once again like tied to the client side and need to do something else on the server. So having a look at the server, as I said, there are a couple of options. 3 big names I have for you: org.json, Jackson, and JSON. Out of those, org.json is really like the de facto standard. It's actually made by the guy who like invented JSON. That one though has a quite interesting twist, because that guy, all the stuff he does has a special clause to the otherwise completely liberal license. It says that the software should be used for good, not evil. And that's something that lawyers have a problem with. So actually, like, he quite frequently, at least he claims that he quite frequently gets contacted by IBM lawyers saying that, hey, you have awesome software, you want to use it. We are, of course, not evil, but we can't promise that our customers won't be evil. So could you please do something about this license? So what the guy did, he mailed them back, said that, okay, I grant you the permission to use this software even if you are evil. And I also extend that license to your partners, your customers, and your minions. But the library we will be looking at today is Jackson that I talked about. This is really like a convenient way of mapping strings containing JSON into any like bean-like Java object. So the way you use it, you create an object mapper instance. If you need to do something custom, you can like customize this instance, say that, hey, this kind of object I really want to like treat in this way instead of just using the standard conventions. But if the conventions are good, then you just say like, hey, here's the string I want to read, please make it into a contact class object, and that's what you get. And as long as you follow like the conventions, everything will just work out nicely. One thing to observe is that how is this implemented? It uses reflection. Reflection is no good in GWT land, because that would mean that the compiler can't know what to optimize away. So instead, basically anything you do in GWT will use a code generator instead. So that's like hooking into the GWT compiler. When it compiles, it actually like sees that, okay, you want to get from contact class to a string, okay, and then that's like generate the code that does the same thing as the reflection magic on the server would have done. One implementation doing exactly this is called gwt-jackson. There are other similar as well. This is like compatible with Jackson. It uses the exact same conventions for like how different structures in your Java classes are sent as JSON. So those two go really well together. The usage is also quite similar. There's some small differences. One is that you need to define an interface with that generic definition so that the generator running at compile time can know for what type it should generate the support. And then when you want to use it, you use the like gwt-create for that class. That's actually what like when the compiler sees that, it knows that, okay, I need to generate an actual implementation of the contact mapper class, and then it creates that subclass for you on the fly there. And then when you actually want to use it, you just say that, hey, please mapper, can I get a contact out of this string? And there's also a method for going the opposite direction. So that's basically it. This has really little boilerplate code. It was just like 3-4 lines of code, except the like definition of the class that you're sending. One other good part is that you can share quite much of this code. You can share like the contact class definition between the server and the client, which means that like you don't get in problems because you update one but not the other. The main kind of problem, kind of not problem here is that still we are just like creating strings, good, but where do we send them? Because okay, you can like manually define that, yeah, okay, at this URL I have a servlet listening to these kind of requests, and then you need to keep those in sync once again between the client and the server. But what you really want to do usually is just have some kind of convention of saying that, hey, yeah, if I do this on the client, then it should find like the corresponding method on the server side and run that without having to like think about what the URL map to that code actually is. So this is actually like a remote procedure call. You just like have the interface defining what you want to do, and then use it on one side and implement it on the other side. And then there's, depending on the solution you're using, there's some kind of convention for how it finds the implementations. One problem with this though is that you can't really get contacts, can't directly return the list of contacts, because we're once again doing this over the network asynchronously. So instead, we would need to return something that like is not the result, but something from where you could get the result later on. So some kind of like asynchronous result. Or then another option, instead of returning anything at all, you pass a callback to the actual method saying that, hey, like run this, and when you have a result, call this callback. And then there's once again like two different options. Either you use the same on the server so that your actual server-side implementation is responsible for calling the callback, or then you have a like parallel interface definition on the server that actually returns the value, and then the framework takes care of mapping that into something that on the client calls the callback that you gave there. Quite complex, I know. But luckily, this is most likely familiar to all of you, because this is really how gwt-RPC works. Gwt-RPC is like the default solution in Gwt. That's what you get when you create just like a hello world application using like, do we have a Maven archetype? I don't remember, but at least like the Eclipse plugin. This is really simple, really powerful, really convenient to use. The bytes that are actually sent over the network, they are very heavily optimized. It does things like string deduplication on the fly. You don't need to care about that kind of stuff. It supports polymorphism. It even has that kind of trick that when sending data from the server to the client, it sends the data in one format, and then the other way around, it uses a different format, because one kind of structure is more efficient to parse on the server, and another kind of structure is more efficient to parse by the browser. So that's the kind of optimization that's going into this one. Some problems though, of course, I won't present any solution here that doesn't have problems. One is that you might actually, like by accident, send your entire object graph here, because you send your contact and then it has a reference to some service that references something else, something else, something else, and suddenly like everything goes over the wire. Another thing is that this approach supports polymorphism, so you can actually like declare in your interface or wherever that, hey, this is some abstract class or interface that is sent, and then the implementation takes care of figuring out which actual subclasses should be supported. The problem here is that if you have a really vague definition, then the generator might need to support all kinds of different subclasses, so this can also cause the generated code that ends up inside your module to be really big. So that's something that you need to be slightly careful with, although in most cases you still get some kind of error messages if it tries to do things that you might not want it to do. The last drawback here is also the same as the benefit, namely that the format is optimized, which makes it hard to debug in case you need to dig down into the details, figure out why something goes wrong. This has actually a couple of other drawbacks. One is that it's really sensitive to having the same version of your like interfaces and that kind of stuff on the client and on the server. It actually like sends in the beginning of the message, it sends like a version number generated-ish thing, so that it immediately detects that, hey, now we are out of sync, can't do anything. But that can still be a problem if you like need to, because you need to deploy both at once, basically. The last drawback, also coming from this really optimized format, is that this is heavily tied to only GWT, so you're quite out of luck if you want to like use a non-Java server, or if you want to support like an Android client or something like that. But despite all this huge pile of drawbacks that I just presented you, this is, according to the survey, the most popular solution. It's even majority solution, so obviously those drawbacks are not that good, or actually the benefits outweigh them. So that was gwt-RPC. What if you want to do like similar thing, but using JSON instead, so that we can use like different servers, different clients? So we still want to have like a way of just defining the services that we want to call, and then the framework takes care of finding out like where to call it, how to send the actual message. So we just have services that we call instead of requests that we send. For this, there's like, once again, a really good like standard. It's not really a standard, but more like a convention. It's called REST. This is just like a convention for like how you structure what you send. So default thing is like, if you want to get just all the contacts that the server has, then you like just send a GET request to contacts. If you want to delete a specific contact, then you send a delete request to the same base / and then some kind of identifier for that contact. So for instance, a numerical ID or something like that. And then if you want to create a new contact, then the convention is to send a put request, and then it's once again to the same URL as the get, but it's a put request, and then in the actual payload you also include like JSON string containing the actual data. How this is done, like implemented in practice, on the server there's this really big thing, part of the Java Enterprise Edition, JAX-RS, RESTful services, blah, blah, blah. This is the most common implementation of this, which is quite often also used standalone without like the full enterprise stack, is called Jersey. And that one actually also happens to use the Jackson library behind the scenes, though you don't really see anything of that as a user. The way code looks for like defining the interface is that you define the path, where should the magic on the server deploy a servlet that knows how to deal with this. Then you have the get. You just say that, hey, when there's a get request for this path, then run the implementation of the list contacts method that has been found from the class path. For the deletion, we say that, yeah, it's the same path, but then also like appended to that path is the ID, and then you say that, hey, this ID is like a parameter, so then you get that as an integer automatically to your implementation of this service interface. And then correspondingly for the put method creating contact, then the framework also sees that, hey, okay, we should actually get a contact from somewhere. Oh, let's take it as JSON from the request body. And this is all like working automatically. You don't need to do anything about that other than like define this interface and implement your class. On the client, we have, once again, this is probably the most popular one. There will be another session about this, only about this solution, tomorrow at 2 p.m. I think. So have a look out for this if you want to know all the details. I'm just showing a brief overview. So resty-gwt is like counterpart to JAX-RS. You can use the exact same service definition if you want to. Just need to add like extends direct REST service interface. That's like a marker that GWT needs to, or the GWT generator used by resty-gwt needs to find out what to do. So then once again to use it, just gwt-create, so you get an actual implementation of the interface. To call something, this is a slightly awkward syntax. That's because of the like asynchronous nature of these things. But still, what you do is that you give the framework, the library. Actually, it's a library. You give the library a callback. You say that here's the like service implementation that I want to use, and then you just send it. So with resty-gwt and correspondingly Jackson, big benefits here are that you can use any server, any client. You can find like compatible implementations for like Python, for .NET, for basically any server-side language you want. And also correspondingly, there's like good libraries for on the client for Gwt, for just plain JavaScript, for Android, for iOS, for anything. So that's really a good part here. One just small problem here is that you have some boilerplate here still like needing to add those annotations that were not needed with the GWT-RPC example. But still, all in all, this is like currently at about 6% usage, and my guess is that this is one that will become more popular over the upcoming years. So this now has been like a couple of basic concepts. First, we just send a string. Then we have some way of getting from the string to your Java objects. And then we also have like two different ways of figuring out or defining where to send that string. With those basics covered, let's have a look at some more like non-conventional ideas. Okay, some of these are quite common, but still like not following this really basic pattern. The first one is that instead of having what you send defined as a class, like this contact.java that we saw, what if we instead define it as an interface and then just like magically get implementations of that interface that like somehow maps the values to something somewhere, just magically. We don't need to know where it is, how it works. This gives us some new like ways of doing things, because here we have like the framework can do whatever it wants when we call a getter or a setter. One thing we can do is that map some of those like methods in that actual object that we have sent over the wire, so that that method directly works as an RPC call that is tied to something. Another thing that can be done here really easily is that like the identity of entities can be managed by the framework, so that you don't need to like have a good equals and hash code implementation. The framework always knows that, okay, if I want to have entity with this ID, can make sure you always only have one instance of that particular entity, so you can know that they are not mixed up. One third thing that you can do is that you can send actually like partial updates. So if I receive a contact entity from the server, then I like do something with it, and then I send it back to the server again from the client. Then the implementation can see that, okay, the only setter that has been run was this one. So this means that that's the only data I need to send back. All the other data has not been changed, so we don't need to waste bytes or CPI cycles dealing with all the other fields. This is kind of the idea behind something called AutoBean, which is also part of the GWT SDK, though it's a separate part. Some like to use AutoBean on their own, but most users of AutoBean, I think, actually use yet another layer on top of that. That layer is called RequestFactory. This is really good for like entities, basically for CRUDs. You can send like, or it's optimized for CRUDs, you could say, though it also works for other things. Here you have like both RPCs and management of those like CRUD entities, and everything is really automated. It's almost like magic. Some problems with this. One is that it's quite complex to set up, so like you need to define several different interfaces. You need to get the exact right annotations in the right places. But then once you have it actually rolling, then it's quite good. So So it has a kind of learning curve, but once you get over it, then it's really smooth. One other problem is the same as with gwt-RPC. You are quite tied to actually having a RequestFactory server as well. And also with clients, actually there is an Android client implementation that would work with the same server, but any other systems you might have to make your own or just use some other system instead. This is also like looking at usage percentages. We are around 7% here, so it's once again like one of the like follow-ups after gwt-RPC that was the majority. The next approach that is also like slightly out of the box is that instead of like actually writing the Java for the things we want to send, what if we instead define just in some like more abstract language, define what it is that we want to send, and then we generate the code that represents that data and also the code that like converts to and from strings that can actually be sent. So this could, for instance, look like this. We define a contact message, it contains a required string name, required integer with the year of birth, a repeated string or repeated strings with email addresses, so we can have many of those, and then an optional street address, and then we would also need to define the address message, but I have left that one out. One detail in this particular format is that it also defines like identifiers, just like numbers in sequence for these fields. The idea here is that you can, if you refactor something, you don't have the year of birth there anymore, you can just remove that row and the implementation can see that, okay, now we have 1, 3, and 4, and then it still knows how to send the message so that it doesn't cause direct incompatibility problems with an old implementation that still also expects to see this field number 2. This system that I described is protocol buffers. Its main benefit probably is that it can really be used by any language. You just like generate code for whatever you use based on that same message definition. So you can use once again like C# or Python or PHP or assembler or whatever you want. Another thing that is probably quite good is that this is really proven in battle, because this is what Google uses internally, like especially for communicating between different servers, between different data centers. This is really like heavily optimized. They have like the actual implementation is a binary format that is really compact, really efficient to like both send over the wire and to generate and parse. And also the last benefit I will mention is the like backwards compatibility that we already saw. So that also helps, especially once again, like if you have different servers in different places and can't update all at once. So then it's really good to have a communication format that actually lets you use different implementation versions on different sides. The problems here, from GWT's perspective, one problem is that the format, the like official format, is a binary format. That doesn't play very well in browsers now, at least for now. Later on, it could actually like be better, but for now, the actual like implementations that you find for GWT for this stuff, what it does is that it has a custom JSON-based format, and then if you want to pass the message on from the server, then the server-side implementation that is like tied to this implementation, that one converts it to a like native protobuf message instead. Last drawback here is that this is not very widely used outside Google. So like in the survey, the number we got was 1%. This could also be on the rise. It's quite new in the GWT community. There has been some buzz about it, but not very much yet. We'll just have to wait and see. The next interesting idea is that what if we instead put the server in control? So instead of like always having a client asking for things, we actually make the server be the one who decides things, and the client just like, hey, can you help me? Can you help me? One aspect of this is that if we have like, this is for instance like some component structure, widget structure, something on the client, and then if we have a server, stateful server in control, it has the corresponding structure. So this means that each part can like directly talk with its like counterpart without having to like, without you having to define like URL mappings or anything, separate interfaces for each one, but instead they can just like directly talk to each other. One thing we can do here is that we can have like shared state that like each of those friends use to synchronize with each other. So this could look like this. We have like contact state class. It contains a name field. These can be public because they are just like internally used, convenient to just not have to write any setters and getters. One feature we can do, for instance, is that we can annotate one of those so that whenever the year of birth is updated, then we also see that, hey, okay, there's a set year of birth method on the corresponding widget instance or widget class, and then that can automatically be run whenever the value is updated. Another way of getting those is to do like a conventional callback, just define like on-state change method for the name parameters. These can be checked at compile time, and then in that method you do whatever you want. One last thing in this particular case that I'm leading up to is that instead of having an interface with generics for defining that, like what is the data type that we are sending, you can also define this like override a method, just like redefining the return type to a more specific one. This is quite convenient with inheritance, so that you can have like a base type and then build upon that, and that's something that is quite tricky if you're using generics. Another thing that can go on between these like counterparts would be RPC. So once again, this is basically the same, just like small variations, some kind of interface defining what is sent, and then on the server just register an like implementation of this service tied to that particular like instance box so that they can talk with each other. And then when you want to call it, just like on the client, get, once again tied to that instance, get a proxy of that RPC interface that is directly then used to send a message. This is how the communication works in the Vaadin framework. By the way, this is my favorite. I just don't know why. The benefits here is that having a stateful server gives you a bunch of like convenience things that are really good if you want to have them. Another good thing with the Vaadin communication mechanism is that it has built-in server push, so you can like initiate things from the server. The server can say that, hey, this background job that you started a while ago, now it's done, without the client having to poll for it all the time that, hey, are you done, are you done, are you done? But instead the server can just say that, hey, I'll call you when I'm done. Drawbacks here, same as the benefit, you have a stateful server. Some cases that's okay, some cases it's problematic with like scalability or clustering or those kinds of things. It really depends on your application. And here also this is really heavily tied to the framework, so you would probably not want to just use Vaadin communication mechanism without using anything else for Vaadin, because that would be quite complex. I have proven that it can be done, but you don't want to do it, I think. The next and actually final example I have is, what if we completely forget, or not forget, but completely like abstract away everything that has to do with communication? Just the thing we could want to do is to send CDI events. CDI is like part of the Java Enterprise stack again. It's quite convenient way to have like decoupled event sending from anywhere to anywhere. So to fire an event using CDI, you need to inject an event instance tied to a specific type. And then when you want to send events, you just like call fire on that and pass in whatever event you want to send. And then somewhere else, wherever, just like in the same CDI scope, any method that has this observes for the same parameter type will get called automatically. You don't need to do anything to like register the event handlers or anything. The cool thing is that the guys at Red Hat have figured out a way of doing this between the server and the client. So this is Errai Bus, which is like one part of the Errai framework. This is really cool because you don't even realize that, hey, I'm sending messages between the server and the client. I just like send CDI events and they just work. So once again, we have a really, really transparent communication. You don't even need to know that you are doing anything over the wire. And this framework also has like server push built in, so everything just works in both directions. Drawbacks are kind of the same as with the Vaadin case. One is the same as the benefit. Drawback being that, oh, you could actually like by accident be sending stuff that you don't realize that, oh, I was actually sending this to the client as well. This should have stayed on the server. There are mechanisms for controlling that, but you might still by accident screw something up if you're not careful. And the other thing here also is that this is just like one small part of the framework, and it's really like all or nothing here as well. You could, if you really want, could use only this part, but most likely if you go that route, then you would want to use everything from it. That's all I had to tell you. So small summary again. We have been looking at like basic cases, getting strings sent and received, constructing those strings, seeing how to figure out how to define where those strings are sent. And then finally, we have been looking at some like more interesting approaches that might or might not be suitable for your cases. So with that said, would any one of you have anything you are wondering? Any questions?